right? So 2.8 chemistry. 1 is a thing called dimensional analysis, and then everything else is old. The temperature scales, we have Celsius, 0 is freezing, 100 is boiling for water. Fahrenheit, 32 is freezing, 212 is boiling for water. Kelvin, 0 Kelvin is negative 273 Celsius is absolute 0. I didn't say this. I think this is true. I might be lying. It might be an urban legend. I think Fahrenheit, the goal was like 100 degrees be body temperature, and they made stuff around that. Like, I don't think they were aiming for 32 to be freezing. I mean, it is. But I think he was aiming for 100 to be like an average body temperature, but he missed by like 1.4. Maybe he was running a fever. I don't know. But 98.6 is the traditional body temperature. But that's at least an urban legend. Maybe I just repeated as something I don't know is true, because I just sort of blurted that out today. 9, our equipment's mass is some sort of a balance. Weight would be a spring scale, some kind of scale is good enough for me. Volume, you have a million choices of burrets and pipettes and cylinders and cups and this, that's, and the others. Temperature is thermometers, length is rulers. 14 to 17 would be anything other than 0. Zeros that have bars written on them. And then 2 that you have to be careful how you say them, that I said I'd be fussier this time. So zeros between other sig figs is a win. Zeros between other digits is a loss. Then the other one is zeros at the right end of a decimal number, which you might be able to say other ways, but the way I just said it is certainly correct. Zeros at the right end of a decimal number. 18 is the round first, and it's based on place values. 20 is rounding last. It's based on counting the sig figs, or finding the fewest sig figs in one item in the problem, something like that. I'm flexible on that. 22 is to write long numbers in a short way, or to write big and small numbers in an easy way, something like that. What you can't say is it makes big numbers into small numbers, because it's not changing the values of the numbers. It isn't turning big numbers into small numbers. It's writing big numbers and small numbers both in an easier format. 23 rules on that are you have to have a number from 1 to 10, and 10 itself is out of play. Always times 10 to a power, and if the power is positive, it's a big number. If the power is negative, it's a small number. Question about storing that?
For the digits are significant numbers, if they say zeros on the right of numbers after a decimal.
Yeah, that would do it.
Okay, good.
Anybody else a scoring kind of issue?
That's 25, right?
Out of 25, yes. So quiz tomorrow is out of 24, even though we gained some new things. So what's going on for tomorrow? Read 2.9. 2.9 will have 1 new point. And then after you're done with 2.9 and the chapter seemingly ends, keep reading. There's going to be a box about the Earth's atmosphere. So you'll get some kind of open-ended question on that, like tell me stuff about what was in the box, kind of stuff. No, it's actually a specific 3-part question. So there must be an obvious 3-point answer to that. But three points in the box, there must be an obvious 1, 2, 3 on it. Then keep reading. There's one of those elements. It's after the homework problems stop. It's actually a compound, not an element, but maybe you don't even know the difference yet because we're so early into chemistry. But there's a blue box about a thing that they say is an old friend, according to the box. But there'll be 2 points out of the box. So 1 point from 2.9, 3 points about the Earth's atmosphere, 2 points about the box. And then, compared to today's, I'm going to ditch 2 to 13, bye-bye. From 14 down, I'm keeping all the 14 down stuff. And then I'll have 1, 2, 3, 4, 5, 6 questions built off of today, some of which are already on the board over my shoulder. So one question, number 1 will go backward. It'll say, what is dimensional analysis? So it's a method that converts from one unit to another, something like that. Lets us turn grams into pounds or millimeters into kilometers. If we're converting from one unit to another, dimensional analysis is one way we can do that. I have a common sensey kind of question that we can use sometimes instead of doing math for some people, if you're a common sensey sort of person. If we do unit conversions, if the unit gets smaller, what would have to happen to the number? If you have a unit that gets smaller, the number actually has to get bigger. So if I told you that from here to the football field we play on today is like 4 or 5 miles, and I want to convert that to inches, the inches unit is much smaller. An inch is much smaller than a mile, so the corresponding number is going to be way bigger. So if it's 4 miles to the football field, it's like 1,000,000 inches to the football field. I don't know what that is, don't feel like converting it. But that's a question. If the unit gets smaller, you could say the number has to get bigger. Or if I play it inside out, if the unit gets bigger, number has to get smaller. There's a balancing act to that. Then I'll ask you for 4 formulas. This is the formula for Celsius turning into Fahrenheit. It's ready-made for you to plop in a Celsius number, do math, and out comes Fahrenheit. This would be a formula for turning,
Celsius into Fahrenheit?
now this one's Celsius into Fahrenheit.
Fahrenheit into Celsius.
So this is turning Fahrenheit into Celsius. We would drop in the Fahrenheit number, do the math, out comes a Celsius. This would be a formula for turning Celsius into Kelvin. You drop in the Celsius, out comes the Kelvin. And this would be a formula for turning Kelvin into Celsius. People that have survived physics, sometimes in chemistry, the best way to change from one unit to another is still what we did most of last year, memorize and then utilize some kind of an equation. Okay, that will at times happen in chemistry. That will not be nearly as dominant. Okay? But for these conversions, your best bet is memorize, utilize some equations. So people with calculators handy, let's push some buttons to practice this. The homework tonight is going to be a ton of unit conversions. So the homework today includes a 1M single vocab hit. And then from 19 to 33, you're converting all sorts of stuff into other stuff in terms of some systems and measurements. And some of those are single hitting questions. Some of these have like an ABC component to them. But not all of them. It's not like A to G or something on all of these, but some of them have an ABCD aspect to them. So if I gave you 20 Celsius, which equation number would you use to get a conversion made? Top. So somebody push some buttons, 20 degrees Celsius, out could come a Fahrenheit, it is 68. Anybody need any help to make that magic happen with your machine? There's punctuation hidden by the way I wrote it, but your calculator will need it. What punctuation would your calculator need? Parentheses around the whole talk. So if I give you 86 degrees Fahrenheit,
30 Celsius.
you're going to run equation number 2. It is 30 degrees Celsius. I agree with that. Question about doing those conversions? Some of the homework will do that, and for sure that'll make the test. The only really good way to do that is know the formula and just run it. Celsius and Kelvin, when you memorize this, here's one helpful tip. Kelvin can't go below zero. Kelvin can't go negative. The lowest Kelvin temperature that exists is a thing called absolute zero, which is 0 Kelvin. So Kelvin can't ever go negative. Can Celsius go negative?
Yeah.
Yes. So when you go to make Celsius, subtracting 273 is fine. And if you go negative, no one cares. But when you make Kelvin, that has to be done by adding 273 because you can't go negative on Kelvin. So I have Celsius, I want to make it Kelvin, I'm gonna add, that'll get me 303. And what's one weird thing that I did mention another day about the punctuation on Kelvin?
There's no degree.
There's no degree sign, just a K. So if I drop you 400 K,
127 degrees Celsius.
127 degrees Celsius. We're not going to memorize a formula to take you straight from Kelvin to Fahrenheit or Fahrenheit to Kelvin. I think one homework question in this chapter will ask you to do that. So how would you get from Kelvin to Fahrenheit or Fahrenheit to Kelvin if I'm not giving you an equation to directly do that?
Celsius to switch it.
Use Celsius as like your middle star. So you make whatever to Celsius and then Celsius to the other one, because Celsius can play with anybody. Question about that column of stuff. Middle column of stuff. You can either do with what I'm going to call dimensional analysis. I didn't call it that. Everybody in chemistry calls it this. I'm going to do this first with dimensional analysis, second with common sense. If it's just metric stuff, you can get away with common sense. If it's not just metric stuff, you need to understand dimensional analysis. So this is like a breakthrough sort of day. Good news for the people who haven't had physics. We never did one-dimensional analysis problem in physics. Dimensional analysis gets isolated in chemistry. So nobody in the room has ever done this before with me. Okay, so this is brand new for the whole world. So here's dimensional analysis. It's like you draw this big line and then you separate it into some pieces to do some unit conversions. So copy what you're given. 3 centimeters goes in that first top slot. Generally nothing underneath unless you're given a fractional thing. If I gave you something that was fractional, we'd fill top and bottom. And then we're imagining like fraction life. What's the key move when you're multiplying fractions?
Multiply straight across.
Going straight across is a key. What's
Canceling
another?
out.
Canceling out is a common thing. So what this is, it's a replication of doing some fraction moves, fraction cancellations. I'm giving you centimeters and I want centimeters out. So to cancel centimeters, I would need to put more centimeters on the bottom. So centimeters go out, and then you'd ask yourself, do I know something that can take me centimeters straight to meters? Can I get straight from centimeters to meters with numbers that you've memorized on metric quizzes? Yes. So you do. It involves 100. The question is, do 100 meters make 1 centimeter? Or do 100 centimeters make 1 meter?
100 centimeters.
100 centimeters make 1 meter. So this is called a conversion factor. We'd set up our conversion factor that way. And that's all we're going to need for that. If the numbers are on the top, you multiply them. If the numbers on the bottom, you hit the divide button. So I'd punch 3 divided by 100, and out comes 0.03 meters. And there's 1 down, 1 to go. I'll double back and do that a different way. That's pure common sense in a second. Something about that. So if I want to turn 6 kilometers into centimeters, what goes in square one is 6 kilometers. I need kilometers to go. So I'll put kilometers on the bottom. You do not know any way to get from kilometers straight to centimeters. We've never memorized that. So we need to go to the base unit, which is meters. And then ask yourself, kilo, what's that number? 1,000. And just make sure you get it in the right spot.
So
Does it take 1,000 meters to make 1 kilometer, or does it take 1,000 kilometers to make a meter?
1,000 meters.
1,000 meters make 1 kilometer. Then we're going to need to go another level. We're halfway home. Question, halfway home? Then meters have to go out. So put meters on the bottom. And we want to bring in centimeters. And we memorized centa has something to do with 100. Just get it placed in the right spot. 100 of who makes 1 of who? 100 centimeters makes 1 meter. Since all I have is ones on the bottom, all I need to do is multiply and go 6 times 1,000 times 100 centimeters, winner. 50-50 whether I would do that way. Question about that? If you're comfortable with that, dimensional analysis will never let you down. When we do turn the camera a smidge and take on this next column, I will absolutely do dimensional analysis. I'm not going to try to shortcut anything. I'm going to just do it the way we were just doing this. These two, I might take a shortcut based on the theory of common sense. And all you're going to have to do with the metric system, since it's all tens, what's happening with the metric system?
Moving the decimal.
It's just moving the decimal. And you just have to make sure you move it the right way and by the right count. So, centimeters are little or big compared to meters. Centimeters are small. Meters are bigger. So the corresponding number with this big unit has to get a smaller number. So we need a smaller number than we presently have. Centa's number was 100. Has how many zeros?
2.
2. So take the decimal and pop it 2 spots to make it in a smaller number kind of direction. That's what I would do for that one. But if you're not comfortable with that, just do the dimensional analysis, it's fine. Reanalyze kilometers compared to centimeters. Centimeters are small. So the answer we see must be a number that's big. Kilometers is in the whole number part of your memory with how many zeros? 3. Centa is in the fraction part of your memory with how many zeros? 2. So how many places apart are they truly? 5. So we need to take this decimal and move it 5 positions. It'll add 5 zeros. We'll get 600,000 on that. That only works with the metric system because the metric system is based on those tens that it just takes the decimal point slide. As soon as I get into this next column of problems, it has nothing to do with tens. We're just going to have to do this dimensional analysis thing. You will probably this year draw like 1,000 of these. I don't think I'm exaggerating that. I truly think you'll probably draw this structure 1,000 times. Sometimes it'll be about that big. You know, where you're like canceling, recanceling, like that's gonna happen. Not usually, but I bet you'll have one that's like 6 blocks long at some point. Question about concept? So I'm out of the book now for some more math. So there's an example 220. If you want to join me, you can. If you're just going to listen and follow along, that's fine. But example 220 says there's a cube of iron. It measures 2 centimeters on each edge and has a mass of 62.9 grams. And they want us to calculate the density in kilograms per meter cubed. This is about as mean as they could be for a density question. So we need to dust off an old fact. So density. We've had on quizzes, we haven't had it in the last couple of
Mass
days.
over volume.
Density is mass divided by volume. So if they're asking for the density in kilograms per meter cubed as the goal, it would be nice if they gave you the mass in kilograms. Unfortunately,
They don't.
they gave us the mass in grams. So we're going to need to take 62.9 grams and turn that into kilograms. Either by doing a dimensional analysis, which I'm going to choose not to do this time, or just by common sensing this a smidge. Kilograms? Kilo? Is that a big or little?
Yeah.
That's a big. So the number must be small. Kilo has how many zeros?
3.
3. So let's plop this in the small direction, 3 spots.
69.
0.0629. So there's kilogram. Then for volume, it'd be nice if they just told you the volume. They did not. So how do we do volumes? Volume equals length times width times height. We'd like this to be in cubic meters. So it would be nice if they gave us the dimensions of the box in meters, but
They didn't.
they don't. They gave us the dimensions of this box in
Centimeters?
centimeters. So 2 centimeters, we need to turn into meters.
0.02?
It is 0.02. Since meters are big, the number is small, centa is 2 spots, move it left twice, it is 0.02. At least it's a cube. What do you know about cube sides?
You did the same.
They're all the same. So the volume of this cube would be 0.02 cubed. So that's gonna be 0.00008 centimeters cubed. So then how would we do the density? Mass of 0.0629 divided by volume of 0.0008. And hopefully out comes like a 7,860 if you want to punch some buttons with me. That's kilograms per meter cubed. One thing you do want to get used to in chemistry, and again, physics people, you're already going to be pretty good at this. Every answer should have a number and a unit. So never just give me a number. Everything's going to have a number and a unit, a number and a unit, number and a unit, every time. Numbers and units, over and over and over again. That's the worst problem of the day by far, because there's just a lot of steps there.
Or if it's gonna exactly that.
It would round to that. That's like the third,
Oh, if
third
you're round,
position.
you're
It
right.
rounded to the third position.
Okay.
Question about that one? Okay, then we'll do a small camera turn and do some more dimensional analysis that's like unavoidable, can't really shortcut it. So they say calculate the volume in liters. So you want to always focus on the units in these paragraphs. Liters is our goal. We have 880 grams of benzene to start with. So 880 grams goes in this first spot because that's the only number that we know. And then they give us a conversion factor. For this benzene at this temperature, you get 0.88 grams for every milliliter. You do not have to memorize that. Okay, so like 100 centimeters in a meter, you're expected to memorize that. Nobody's memorizing anything about benzene. They will give you the benzene conversion factors if they want to play benzene games. So dimensional analysis, grams lives here, which automatically means that
Grams is on the left.
grams is on the bottom for our next step. They give us on that page a conversion factor that grams can be turned into. Anybody join me on page 38? What if they give us a number so grams can turn into grams per milliliter. We're upside down, but it's still grams, milliliters, we have a conversion factor there. They told us that it's 0.88 grams per milliliter. If you demand a number for milliliters, it's an implied 1. So grams is out, milliliters is in. Ask yourself, was milliliters the goal? No. So milliliters has to go out by putting its partner on the bottom. And ideally, we want to turn this into liters. Can we turn milliliters into liters? Yes. So what's the milliliter liter number? 1,000 milliliters make 1 liter. You don't have to punch in anything with the ones, but anything on the bottom row, hit the divide button. Anything on the top, hit a multiply button. But 880, divide by this, divide by that, and we're hoping out comes a 1 liter. Something about that. Sometimes, is it possible you might be able to just reason these out? I'd say yes. Is it a good idea to try to never do dimensional analysis? I will say no, that's not a good idea. Just embrace it as a tool you are going to use like a lot, and it will be the best tool often. If it weren't the best tool, I wouldn't tell you that. I think you know me enough and have had me in it for enough stuff If it doesn't have to be written, I'm not a huge fan. I like just writing stuff for no reason. I absolutely will embrace and just do dimensional analysis because it's the best way to be the most accurate with these problems and not get lost in your internal computations all the time. 222 says you have 0.156 kilograms of bromine. So I'll write down 1.156 kilograms, and automatically kilograms is going to go on the bottom. And I'm going to look around in this question for something I can turn kilograms into. I know I can make kilograms into grams, but is there anything in this question that I can also do with kilograms? Do they give me any kilogram conversion factors? No. So the only thing I can really do with that is turn kilograms into grams. So kilograms is out, grams is in. Number for that?
1 and then 1,000.
1,000 grams make 1 kilogram. And then I cross my fingers and think, please ask me for grams, because if they ask me for grams, I'm done. And I look, and I'm almost always disappointed because they want milliliters. So grams have to go out by sticking its partner on the bottom. Do we have a way to get from grams to milliliters in this story? Yes, because they gave us a number. What number did they give you that helps you make this jump? 3.12 grams make 1 milliliter. You don't even have to write the 1.
And then
So for button pushing, this times that, divide by that, out come some numbers. I'm going to say, hope the book's right with 50 milliliters. We good there? So let's go again. 2.23, example on page 39 now, says we want milliliters. I'm giving you kilograms. So kilograms are going out by sticking that on the bottom. I know I can make kilograms into grams. That may or may not help us. Scan the story first. Can they get us from kilograms to something else?
No. Wait, I don't know.
Yeah, there's a conversion factor.
Okay. I was just guessing.
Kilograms getting us to, huh, huh, huh.
Wait, what page are you on?
You'll have to look at 39.
kilograms over meters.
Kilograms over meters cubed. So what that's telling you is 1.49 times 10 to the third kilograms
Oh.
can be turned into 1 meter cubed. So kilograms out, meter cubed is in.
Oh, I don't like that.
Then we need to get the meter stuff to go bye-byes. What they want is milliliters. Scan your quiz memory banks for milliliters. And there's a reason why I made you do a quiz question several times. What's milliliters about? Centimeters. Milliliters, centimeters have a link. So we need to get from meters to centimeters so that we can eventually get from centimeters to milliliters. And there's, now our structure is getting a little longer, and now maybe you see the value in this, because to run this all in your head, you're going to get lost in your internal conversations at times. So meters can get you to centimeters, centimeters can get you to milliliters. What's the number for centimeters? 100. Why is this not quite fair?
Because it's not meters cubed.
It's not cubed, but come back to that in a second. This would be 1. So 100 centimeters makes a meter, that's fair. But if this is cubed and this isn't cubed, we need to cube this. And in fraction life, if you cube the bottom, you've got to cube the top.
So it's 100 cubed.
It would be 100 cubed. What was true about centimeters cubed versus milliliters?
It's the same.
It's 1 to 1. You don't have to write the ones, but yeah, that's a fair trade. So we would want to go 1.25 times 100 cubed, and then divide by that scientific notation-y thing,
839.
839 is what the book says, so we'll score that as a win. Then I'll do one more. I got 2 minutes till a bell, so that times out about perfectly. And this one is way shorter. That's like the biggest bad boy of the day. Debatably harder than that density question that I said was probably the hardest one. That was debatably harder because of the cubing, especially for a minute. If I lost you on the cubing, that happens like less than 1% of your problems in the year. So that's like not a huge deal. If you were with the cubing, great. But if I lost you on the cubing, like 99.9% on your grade is now your new goal because we're figuring it out another day. 224, what should go in the first slot is 400 milliliters, which means automatically milliliters goes downstairs. I'd always look for a conversion factor in the story before I'd scan my memory banks. Do you have a conversion factor in the story with milliliters involved? 1.26 grams for every 1 milliliter. And then I cross my fingers and think, please ask me for grams. And they do, thank you, finally, we catch a break. And we just do the math, and out comes 504 for the grams. That's the kind of thing you're trying to work on this 19 to 33. Some of them are going to be equations, Fahrenheit, Celsius, Kelvin, Celsius, just run the equation. But most of this is going to be dimensional analysis. If it's just pure metric system, feel free to use this whole bigger, smaller, just slide the decimal. That's going to be faster. But if you get lost which way you're moving the decimals, don't ever try to do that. Just dimensional analysis does indeed need to be your friend over time. 2.9 is the read, 19 to 33 is the homework. It's pretty much a wrap unless anybody has questions. Shut that down and get scores before you run away.